help of these specialists for doing the investigation to their interest. Uh, in our country, so far, conventionally, whosoever is doing consultancy, they are only involved. Uh, it's not a specialist field so far. Uh, just a minute, I think. Yeah. So the broad content of my presentation is given here. I will be first talking a bit about the ancient history, about how construction industry has progressed, learning from failures. And then I will be defining what forensic structural engineering is all about, what is defined as a structural failure, how the failure origins, what are the various sources of errors and cause of failures. And in the end, I will talk about a failure education for students and practitioners. This is the broad outline of my presentation, and I think I should be able to complete this in about an hour's time, and then we can take question and answer. First, let me talk a bit about the history. Uh, you see, failure of constructed facilities are being witnessed ever since mankind started constructing the facilities. So I will take you make you walk through the history a little bit. Uh, we all know about the Egyptian pyramids. All of us must have heard about it. The Egyptian civilization was one of the richest and the most powerful civilization in the world in the beginning, in some 2000 year BC. And those period, the Egyptians used to build pyramids, and we all know about it. Uh, until about 18th century, by the way, whatever constructions were being done, they were more based on trial and error process, and people, I mean, there were no structural engineers, qualified structural engineers, so to say. They were builders, and they used to build, and some of them used to fail during construction. They would have learned from the failures, and they would rebuild with more strength, and that is how the learning process began. Now, these massive pyramids, very interestingly, the history of the Egyptian pyramid is that initially, when they started the building pyramids, they used to build it in two slopes. If you see the picture which is here, you can see that in the beginning part, the slope is around 54 degree, and then after certain height, they take an angle of about 43 degree for the building. So initially they started like that, and three or four such pyramids failed. As you can see, one failed pyramid. Uh, and then subsequently they changed this design to 43-degree single angle pyramids, and that pyramid survived. So they have abandoned some four or five pyramids like this, and I mean, these evidence is available historically. So it shows very clearly that learnings from failure has resulted in revised design with different angle, a more stable angle by which they succeeded. Another example I give you is this is in 290 BC, 292 to 280 BC. This Colossus of Rhodes was constructed in Greece. This is a bronze model, the bronze, tower, which is, I mean, we don't have a photograph, but we have an artist's view. And this was one of the seven wonders of the ancient world. The towering Colossus of Rhodes was a statue of Greek titan Helios, and that stood about 900 feet. I mean, it is precisely 98 feet, and that was the tallest structure for quite a long period till it collapsed. Unfortunately, it collapsed only after about 50 to 60 years after construction. That is due to earthquake. It collapsed in year 226 BC. But this was left there until removed and sold much later, about 800 years later. The Colossus of Rhodes was, having such a big impact that even today the country is thinking of rebuilding this particular sort of, to create or to sort of ensure that the historical story remains. So there is a talk now to rebuild this particular statue even today. And by the way, this was the structure which inspired much later, the Statue of Liberty, which was built in New York. The third example which I give you is in 480 BC, this bridge of Xerxes, which was built by King of Persia at that time. The bridge was needed by the king to cross the Strait of Dardanelles in Turkey. If you, I don't know how to show this. This was a link at this point. This was at the location which is called the Hot Gates. It used to be called the Hot Gates. And this pontoon bridge was, you can imagine, this such a long bridge was being built by, by tying with ropes. The ropes were made of plant products. And unfortunately, one fine day, due to some storm, this bridge failed at some or one or two points. The bridge collapsed, and the king was so angry that he killed the builders involved at that point of time. He ordered, in fact, he was a little crazy. He ordered that the strait itself should be punished and whipped 300 times and to place it in slavery. And but he also then engaged other builders and engineers and finally completed this bridge uh, despite all these odds. Another example of how people have learned from failures. This is a very interesting case of Hagia Sophia in Turkey, a structure which is still in existence and a very prominent structure in Turkey, which was originally constructed in 360 BC, and in last 2000 years, this was converted from different religion groups, three groups already, and now at present, also this structure exists in the reconstructed form, which is not belonging to any religion, but it is a secular sort of tomb. But the recent announcement, as late as August 2020, the Turkish president has announced that they will reconvert this from a museum into a mosque. At present, it is basically a museum, which is representing secular sort of credential, no particular religion. But earlier, it started as a tomb, as a sort of a church, and then followed by a mosque, and now it is a museum, and it is likely to be converted to a mosque again. Very interesting story. Damaged three times and reconstructed every time, and every time there is a learned from in the rebuilding. Finally, I would end up this ancient history by quoting or by mentioning about a famous scientist Galileo Galilei. We all have heard about him, but he seems to be the originator of this concept of forensic structural investigation. He, in fact, observed several breaking things. He was a master mathematician. He had written many theories, mathematical theories, and he realized and put it in piece of paper that these, the concept of, bending moment, shear force, and how a cantilever, if you keep on increasing the cantilever, you need to increase the stiffness of the beam. Yes, you need to increase its high depth, etc., so that it is stable. And in fact, very interestingly, he related all this to the nature by saying that, you see, there are trees which are very tall trees, and if you see the girth of that tree vis-a-vis a plant which has got a smaller girth, so he related that how a structure size and scale depends on its stiffness and flexibility. A very interesting kind of story which is there on paper. And that is how this concept of forensic structural engineering began historically. And this story goes back to some 64 to 1642. So it was in this 16th century when the seeds were sown for forensic structural engineering. Now let me get into the more uh, focused attention to the forensic structural engineering. What is forensic structural engineering all about? By definition, the word forensic has come from the Latin word which is forensic, and applies to public forums of discussion, debate in the administration of justice. So naturally, it is related to investigation. It is relating to identifying the guilty, and it is related to rendering opinions and giving expert testimony. Uh, Whether failure occurs during construction or during their service life, it is almost always followed by engineering investigation and resolution of the claims. The findings inevitably create claims of damage and often result in disputes and legal entanglements, and therefore the profession of forensic structural engineering is not merely technical. It is also legal, it is also contractual, and it involves a good understanding of the legal process, the ethical issues. There are so many things. It's a very complex subject, but it is very interesting and very fascinating, because it just not involve it's not a question of saying that this has failed because of this. That is one part of the forensic structural engineering. The other part is to identify who is responsible for the failure, and the third part is to render opinions. And also, it also ends up by identifying what are the areas where improvement is needed, and what are the lessons that we learn from the failures. So this is an interesting part of forensic structural engineering. uh, any structural failure that happens, it causes damage to not only the structure but also to loss of life. It involves delay in the construction process. Anything where there is a collapse, the whole process gets delayed by year, 2 year, 3 years maybe. It involves loss of income by all stakeholders. It involves disruption of service of traffic, uh, personal injury, and loss of life. And all these comes down to finally, if you want to sort of assess the a quantum of damage, it comes down to money. Now, what? I mean, if there is a collapse, what happens? It is it is reasonable that the damaged party wants a restitution. The party who is allegedly guilty, or the person, say contractor, is first uh, fingers points towards the contractor, allegedly guilty party, and he wants to minimize its exposure. The damaged party makes a claim. I mean, the owner client will make a claim, and the guilty party, the allegedly guilty party, will put up a defense, and therefore all this results in dispute. And what forensic structural engineer's job is to untie this dispute, and to sort of bring it to a closure. So, as I mentioned, the profession of forensic structural engineering is a very fascinating profession. Uh, this is one such profession where you have to listen like a lawyer and think and talk like an engineer. Both the professions are sort of have a role to play. It requires a lot of knowledge and skill. It requires a huge experience of what is the practice, state of practice. You have to finally give judgment. So therefore, you have to keep your mind open, and your intuition, your passion, and your education and training. All these are extremely it will be required if you want to be a good forensic structural engineer. It has become an emerging field, as I mentioned in the beginning, worldwide, because There are a large number of failures all about the world. We can see, in fact, in India, in last 4 5 years, we have seen number of failures. The number of failures keeps on increasing with time because of the fast pace of construction, and the kind of attention that is needed is not given. This results in series of failure. With time, there is a complexity of design and construction. More and more, the construction is becoming more and more complex. The need for technical support in litigation is obvious, therefore, because there are more number of failures, and the recognition that the failures can be mitigated if we use the lessons learned from properly investigated past failures. In fact, every failure gives us a lot of lessons, but the question is, are we learning these lessons? Are we really taking action? The idea of this forensic structural engineering course in academia is only to highlight this fact that from each and every failure we should have a learning, and we should improve upon it. The number of failures should reduce with time. Whatever mistakes identified should not be repeated in the next case, and that is the whole idea of studying case studies on failures. What I want to mention here is, I mentioned that in India in last couple of years there has been series of failure, and in last 1 year, in fact, I have compiled, these are the 6 projects where I am personally involved, uh, somewhere as a designer, somewhere as a review consultant, and somewhere as an expert committee uh, post failure. In all these cases, very interestingly, all this happened in last 1 or 2 years. You can see the dates: 22nd uh, August 2020, 15th July 2020, 19th June 2019. All these happened between 2018 to 2020. So many large number of failures in, this is only in bridges in highway sector, and this is only a tip of the iceberg. I mean, if you see the total quantum of failures almost every day in the newspaper, you see somewhere some building has collapsed, somewhere some bridges have collapsed. This is uh, okay. So, due to the lack of an accredited process for forensic structural engineering in a reasonable scale, unfortunately, we are not learning lessons from the past failures. And there are numerous cases in which individuals have been convicted and sent to prison wrongfully. I remember a case in Mumbai where there was a failure of a pedestrian bridge, and there was so much of pressure. Media has blown it out of proportion, and with the result, the very next day, the structural engineer was behind the bar. An investigation would take place later. Well, nobody knew at that time whether it was really a fault of the structural engineer or somebody else. And it is also possible in this process that there are just as many guilty who goes scot free just because the proper investigation do not take place. So it's very important that the profession of forensic structural engineering is taken seriously. Now, I just want to mention a little bit about what is standard of care of a professional structural engineer. There is a lot of confusion in this, and I thought it fit to sort of flag this issue. What is standard of care? That is a level or quality of service which is ordinarily provided by other normally competent practitioners of good standing in that field when providing similar services with reasonable diligence, care, and best judgment for the purpose hired in the same locality at the same time and under similar circumstances. Violating this principle is negligence. Now, what does this mean? In short, what this means is that suppose there is a collapse which has occurred, and somebody is doing an investigation, and during the investigation, he or she comes out with a very sophisticated theory of analysis, carrying out a three-dimensional finite element analysis, and he proves that the designer did not do the three-dimension finite element analysis, and therefore, in some places, the structure stresses are little high, and that is a fault. That is not what is expected. As a professional forensic structural engineer, when you are investigating into a case, what is expected from for you is to look at the structure and its analysis based on what is the standard procedure being followed in the country, in that particular country. What is being followed in India may not be same as what is being followed in US. And therefore, a structure which has failed in US, the process procedure for forensic structural engineering may be different from the process and procedure being followed in India. And the what matters is the standard of care. The second part which I wanted to mention, that the public and the expert has to understand that when one hires an engineer, one purchases a service and not insurance. So one is not justified in expecting perfection or infallibility. No engineer is infallible. I mean, if you are doing a design, it is possible that you commit a mistake. Structural engineers are not infallible. Only what is expected from engineers is the reasonable care and competence. I mean, there should not be negligence. So within this purview, you have to understand, I mean, whether a person, you before you hold a person guilty, you have to understand this. What how do you then, one can argue that how do you prevent mistakes, if you are saying that if you do some work you are bound to commit mistake, then how do you prevent mistake? So the system should be available to prevent mistakes, and that is why in the system, when you design, somebody will design, and in the same organization there will be somebody who will be checking, and it will be approved by somebody. All the three involved have to have their due diligence, and thereafter it goes out, and then there is a proof checker who has to do his own independent check, and all these process should ensure that the final outcome is free of mistakes. As an individual, when you are designing, there is a possibility that you may commit a mistake. I mean, after all, to err is human, but the system should prevent this a bad quality of work. This is all we have to understand. Output, what is the output of a forensic investigation? These are what is bulleted here are the likely outputs whenever you do a forensic investigation. The status of construction at the time of failure, external actions at the moment of the failure, what are the internal stresses or forces acting at the moment of failure, what is the capacity of the structure, why it has failed, place where the failure was originated, what is the trigger, primary cause of the failure, what are the contributing factors, and finally who all are the people responsible. I mean, this is what is the broadly outline of forensic structural engineering. Now, let us come to the third part. What is a structural failure? Now, there is a lot of confusion about it. So, structural failure is a non-conformity with design expectation or unacceptable difference between intended and actual performance. Always, it is not necessary that structural failure means a literal collapse. Extensive damage, but no collapse is also a failure. Local failure is also a failure. If there is a signs of distress, that is also considered as failure. If somewhere there is excessive deformation but no signs of other distress, that is also a failure. Unreasonable maintenance needs. Suppose a structure is demanding frequent maintenance which is unreasonable, in a way it is a failure. Or unacceptable aesthetic appearance, that also can be construed as a failure. Now, let me just give you quickly some real life examples of what failure is. For example, this is Vivekananda flyover, which collapsed in 2016 in Kolkata. And this is a total collapse during construction, and this will be considered as a failure. In this particular collapse, some 25 people were killed, and the reason was actually wrong design and detailing, poor material, There was a ghost contractor who was on paper only a international contractor, but not really involved in the project. And this stunning failure was a complete failure of system. Second example where there was a total or partial collapse was that of a building in Delhi where fifth floor was under construction at the time of collapse. This is in the building was 2 floor higher than the legally allowed, and its foundation had been weakened by water seeping from flooding in the region. 67 people were killed and 73 injured. This happened in 2010. And the failure was caused by prolonged inundation of the basement, incipient seepage through the columns were contaminated by sewage water, and bad design and detailing also was found to be the main cause. This is another 2019, that is last year September. You might remember this cracks in Bowajar area of Kolkata that developed while the east-west metro tunnel boring work was in progress. Around 250 people had to be evacuated overnight from 13 buildings in Bowajar area after it developed cracks, and that happened mainly because of the metro construction which was going on, the tunneling of the metro. Uh, Extensive damage but no collapse. This is one example of Verizon building in the USA, which collapsed during this 9/11 damage of the Twin Tower. The debris from the Twin Tower fell in this adjacent building, and it led to collapse of this particular building partially. Another partial collapse, local collapse, DMRC station 2013 September, where the cantilever arm was one of the platform which supports the elevated platform was found to be deflected during a routine inspection check, and this had resulted in sagging of part of the platform, and immediate attention had to be paid. So this is also an example of collapse, but a local collapse. One another example is the Silchar Bridge at Sadarghat, which is you can see the sagging cantilever tip of this very old but cantilever constructed bridges. And let me just tell you that this kind of distress in long cantilever bridges are very common, old bridges, and this is a very interesting case. Of course, this particular picture that you see is a very old picture. Old means about 5 years old, because if I take a picture today, there is an exist another bridge which is adjacent to this, which has come up now, a new bridge of similar type, very newly constructed. So there are now two bridges, not one. This is the sign of distress and excessive deformation of pavement. This is also a sign, I mean, example of what failure is. Soil settlement, we have this Tower of Pisa and Turkey 1999 earthquake liquefaction damage. This soil settlement can cause also failure. This is just an example. Now, this is an important graph which was prepared in 2003 based on extensive survey conducted in USA. And the gist of what it shows is that most of the failures related to partial collapse happens due to, if you see the second graph on the right hand side, you can see 72% of the collapse is due to partial collapse. And if you see on the left hand side, you can see that 63% of the failures are on low rise building. So if we have to really focus on the areas which requires maximum attention, then we should focus on low rise buildings, and we should focus on partial collapses for our sort of study, and also to develop our expertise. These are focused areas, requiring focused areas where attention is needed. Another study, a very interesting outcome is, if you see these risk probabilities of various activities, and these are American data, which shows that structural failure in real sense is only death risk is very, very small. But then any structural failure, it attracts attention of the public. And though the actual you can see that the death due to structural failure is very few, far and few, but then this dents our image significantly as a professional. And of course rightly so, because after all people have they have given, they are trusting the civil engineers and structural engineers to build safe structures for them. And if these structures collapse, then you are actually sort of breaking their trust. And therefore, though the number of structural failures and the death due to structural failures is far little, too little, but their impact is significant, and therefore we should even try to mitigate this. What are the origin of failures? Let's get into the origin. Well, the origin of failure can be in planning, in the system and the concept. It can be in design. It can be design construction interface. It can be draft construction or renovation, or it can be in service, in misuse or abuse and during use. Uh, how does a failure happen? I mean, there is a famous model which is called Swiss cheese model. If you have seen the Swiss cheese are cheese which has many holes, and these holes are not in a specific sequence. So if you keep a few Swiss cheese, you will see the very rarely the holes will match. And therefore, if a light can pass from one end to the other end with matching holes, that means that coincidentally it is a rare coincidence when two or three holes will come in one line. So in other words, though the trigger for failure can be only one, but there are number of other reasons associated which actually cause the real failure. It is not one reason. Any failure investigation would reveal that there is not one reason for failure. There are a number of other associated reasons which helps for the failure. And the Swiss cheese model is a good representation of this. Mainly what we need to worry about is the human failings. I mean, as far as the nature's fury is concerned, we can do very little. We can only do little bit of mitigation. But the human failing is something which we need to definitely take care of. And these human failings can be negligence, incompetence, oversight, or carelessness. It can be greed. It can be disorganization, miscommunication, misuse, abuse, or neglect. Maybe many a times we are using the facility for purposes beyond its design intent, foregoing preventive maintenance. So that is also a misuse and abuse and neglect. Uh, let's go to the source of errors and cause of failures. So, when, where, and why? Let's see. As I said before, errors can be in the very first place in the conceptual design stage itself, or it can be in the detailed design phase or in the construction phase. When we talk about design errors, we can have errors in the concept itself or a bad approach. So these are the various possible design errors. It can be a concept, bad approach, wrong assumption, assumptions not realized. It can be wrong action taken, or wrong strength, unrecognized load path, no continuous load path. That means the flow of forces are not there. It can be a bad numerical analysis, a poor detailing, and like that. There can be omission also, omitting a particular action, omitting a particular behavior, omitting details in drawings. Uh, I mean, there are glaring examples where shop drawing is faulty with respect to the detailed drawing. Detailed drawing is correct, shop drawing is wrong, and this led to failure. There are glaring examples. Uh, Let me just give some examples of design errors. For example, this is a failure which occurred in India in somewhere in June 2014 in Surat. A flyover collapsed, 10 people killed, and this failure occurred due to error in design, wrong concept, and bad numerical analysis performed by a very junior level engineer, which was not checked at senior level at all. And this is a system failure of the procedure itself. The bridge was with a very sharp curvature, as you can see, in plan, this is a very sharp curvature. And the design was done by this junior engineer by making it straight without by ignoring the curvature, and he simply added some 20% to account for curvature. So therefore the behavior itself was not understood, because the moment you have a curvature, there is a overturning tendency, and some of the bearing supports were in tension, whereas if you make it straight, you get all the bearing reaction as positive. Even if you increase by 20%, 25%, that will not sort of reflect the actual behavior. So simply it failed when the staging was removed. Another very famous case is this Hartford Civic Center Collegia, which failed in 1978. And I'm going to give a detailed lecture on this particular mm, uh, case study in another some other time. It's a part of the curriculum. So, what happened is this failure occurred after 5 years of construction due to very heavy snowfall. Though snowfall was not finally, when the investigation happened, it was found that though the snowfall was there, but the design snowfall height was much more than the actual snowfall height. So, the real cause for failure was actually a design error. The steel space truss pyramidal model, which you can see in this particular slide, this was wrongly designed, and uh, there was a problem of buckling slenderness. The slenderness ratio was not calculated correctly. We will go into the details later, but suffice it to say that this was a failure of wrong design, a very bold design done. This was the first roof structure of a gigantic size of 300 feet by 360 feet, done for the first time when it was constructed with a computer. Till such time, computer in such a large scale was not used in the design. And there were some papers which boasted that, this is the first computerized design of a roof truss. But unfortunately, that proved to be a blunder, because many of the errors could not be identified at that time because it was done by computer. It was garbage in and garbage out. Next, this is another design error due to wrong assumption. This was last year in Karam Nasha Bridge in UP, which is the border of UP and Bihar. I visited the site the day after the failure, and a very interesting case. You can see that the articulation, this failed incidentally after 10 years, and you can see at the crack there is no reinforcement, no apparent reinforcement. So after visiting the site, I was wondering how the bridge could survive for 10 years with practically no reinforcement there. Uh, anyway, the, I will skip that slide. Now, there is another bridge, very interesting case of Millennium Bridge in London, UK, a three-span continuous bridge, uh, which vibrated very unusually at the time of inauguration. At the time of inauguration, there were a lot of pedestrians. This is a pedestrian bridge, by the way. And the people realized that the bridge is vibrating laterally, and it was a cause of concern, and the bridge was closed after the inauguration. And then after detailed investigation, it was realized that the transverse frequency, natural time period of the bridge is matching with the pedestrian's natural frequency, and therefore this was a design error. And finally, they used the friction, mass tuned dampers to mitigate this vibration, and then the problem was solved. And after 2 months, it was opened again. This is a bridge in Florida. And uh, this failed during erection. It was a very interesting, iconic sort of bridge, pedestrian bridge, which was all these cable, the stay cables that you see in the photograph, they are all cosmetic. Actually, it is a pre-stressed concrete truss bridge, and it failed during erection of this uh, particular span. And subsequently, when the investigation happened, it was found to be a design omission, underestimation of the demand, overestimation of the capacity, poor supervision by the engineer of record. And this is also a very good case study. And if time permits, in subsequent one of the lecture, I can cover this in great detail. Very interesting case. Error in shop drawing. There are the glaring examples of error in shop drawing. I can show you. This is a bridge which collapsed in 2019 in UP. In fact, again, the very next day I visited this particular site, and I found that the error finally was found to be when the designer converted from design drawing to shop drawing. Then in the shop drawing there was an error, because of which the welding was done wrongly. Location where welding was required to be done was not done. Location where welding was not required, it was done. It was reversed, and that caused the failure of this particular ROB, rail over bridge. You can see some of the photographs here. You see in fact, there there should have been welding here in this zone. Instead, the welding was here. There was no welding here. There was no welding on this side, and that caused a opening up at the tension cord, both at top as well as at the bottom. Now, this is a famous case of the Kansas City Hyatt Regency walkway collapse. I think when if it is in the curriculum, you cannot. I mean, this is a very famous, well publicized case of Hyatt Regency walkway failure, and a lot of papers are there. Again, if time permits, this can be a good case study for the students. What happened here is, according to the original design, the hanger of the suspended walkway was supposed to be continuous and act the way it is shown, in the middle one, this one. It should have been like this, as it is shown originally. Sorry, as it is in the right hand side. This is the same bolt has to go right like this. But during the construction, the contractor, due to some difficulty, suggested a change. Instead of doing this, why can we do this? And the designer, without much thinking, uh, approved this connection, and this was the root cause of failure, because on this nut the actual force becomes double, and this caused the failure when actually there was some function going on, and all the guests were on the balcony seeing this particular function, and that caused the collapse. Serious, I think, a lot of casualty. Some 140 people died in this. So this is what I think this is more clear. You see, this particular tie was supposed to be continuous from one end to the other end with connections, and the nut was supposed to carry only one floor load. But once you make it staggered like this, it has to carry the full load, and therefore the channel connection led to collapse. Uh, there can be construction and renovation errors also, inadequate or ambiguous drawing, no interaction between designer contractor during execution. This is very common. You see, the designer gives some design, the contractor after during execution do not interact with the designer. He makes some assumptions. If there is any difficulty, he makes many assumptions at site and constructs not conforming to the drawings, thinking that these are minor things, but many a times it can lead to failure. Interaction by underqualified persons. Maybe the engineer to whom, the designer to whom he is interacting, he may not be qualified. So the underqualified person may give some instructions which may not be proper. So there has to be a proper document control in the interaction whenever there is a change which the contractor wants at site from in the original design. Many a times the engineer's instructions are not relayed to the contractor, or engineer's instructions relayed but not accepted by the contractor. Unapproved or misunderstood field changes during construction inspection. All these are very common. I can tell you, those who are involved and experienced in the day-to-day design and construction, they will feel that these are very common. Uh, I mean, this is one example of a crane collapse in Delhi Metro, which the accident of Delhi Metro, I think this is a very famous case of Delhi Metro accident which happened in 2009. But after the accident, when the debris was to be removed by cranes, the crane collapsed. This is just a follow up. It also showed that, while removing the debris, also you have to take care about the crane and all. I mean, this all these hasty decisions can lead to failure. This is another uh, bridge collapse in Italy, which happened because during the the bridge was supposed to be lifted and the bearings replaced. But what happened is, during the lifting of the bearing itself, it collapsed, and this is something which is because of the very poor handling of the repair, rehabilitation, or the lifting job by the subcontractor involved. This is a famous case of collapse of Majerhat Bridge in Kolkata in 2018, and which collapsed because of the poor maintenance. The authorities kept on overlaying wearing coat on top and years after year, and when it failed, it was found that the thickness of wearing coat on top of the bridge was something like half a meter, where it should have been only about 50 to 70 millimeter. There are many such cases. I can keep on going, but I think I will try to squeeze it now. This is a collapse of a basement, which very interestingly happened because the uh, the contractor was actually asked by the builder to sort of only repair a column, only to remove the plaster and replaster on the basement columns. The contractors, the subcontractor who was working, instead of removing the plaster, he removed the entire column cover to concrete, and that resulted in the failure of a part of the building. So another example of in-service misuse in Italy, where it collapsed simply because one of the occupant of the second floor, he removed in interior, sort of work in his own flat. He removed one of the column, thinking that it is a redundant member, and that led to the collapse. This is another case of I mean, this is just an example of accidental. Sometimes, your vertical clearance is not available, so the over dimensioned vehicles can go and hit. You can see just example here. And the third one is a deliberate one, which is due to blasting. This happened in 1995, Oklahoma City of USA, where the building was basically blasted by terrorists. So uh, uh, such things, human causes, can also cause failure. Now, just a couple of slides to define what is act of God, because there can be failure due to act of God. There can be a flood in a particular area, unprecedented flood, which can cause failure, or earthquake of very severe magnitude, which can cause failure. But what is act of God? We must understand. Dictionary definition of act of God is an unforeseeable or inevitable occurrence, such as tornado, caused by nature and not by men. Engineers think of acts of God as extreme environmental events that are not possible, feasible, or worth to design for. Is this true? Failures may occur during acts of God, Some acts of God we design for and some we don't. For example, earthquake is also act of God, but we design for earthquake. And unless there is an unprecedented earthquake of very high magnitude for which it is not covered, we cannot say it is act of God. Uh, Uttarakhand floods, for example, is a true act of God in the true sense because it happened due to some unprecedented, though there was, of course, a man-made reasons also for the extent of damage, but the flood was unprecedented, and that caused a lot of collapse, which can be in the true sense called the act of God. But this is one example where you can see after the earthquake in 2002 in Italy, all the structures are standing, but one particular building collapsed. Will you call this as an act of God? Answer is no, because if it was act of God, all the buildings would have shown some sign of distress. Why only one building? So a lot of engineering judgment has to be applied as a forensic structural engineer when you sort of see the case. Now, let me come to the last part of my presentation, which is the failure education for students and practitioners. Failure education in classroom, there are a lot of challenges, because the roadblocks are lack of availability of quality failure data. In India, unfortunately, you will see in many of my presentations the data which I have given are from outside. Why? Because in India, the failures are not documented well. So we do not have the quality failure data from our own country. Not many. Lack of availability of course instructors with significant practical experience to teach forensic course. Despite these obstructions, some of the institutions are offering forensic course as well as incorporating failure informations into their curriculum. And I must congratulate the Siddhartha Engineering College for having a course on forensic structural engineering. And I can tell you that this is the future. I think you will see huge demand for forensic structural engineers or a person with experience and background, educational background on forensic structural engineering, because the kind of speed with which we are constructing buildings and bridges infrastructure, there will be more and more failures, there will be more and more need for investigation. uh, for practicing engineers, the failure education takes on a number of different forms: structural and forensic related conferences, workshops and webinars, continuing education programs, and self-study. So there are two, targets. One is the students, for whom in the academic institution we should have lectures, we should have good course trainers, and also we should have good sort of documentation or case studies of Indian failures. Though we have many from the overseas, but we should have more Indian failures. As far as the practicing engineers are concerned, they have to also learn this art. They have to learn it through the forensic related conferences, workshops, continuity education programs, and a lot of self study is required. The goal for practicing engineers when studying failure is not to become a forensic engineer, but to learn from failures in order to become better engineering designers. It's not necessary that you are learning forensic structural engineering just because you want to become a forensic structural engineer. There are so many lessons that you learn from failure if you study, that when you are designing yourself, you can take a lot of cue from your studies. There are several guidelines available, and I think American Society of Civil Engineers is the pioneer in the study and the field of professional practice of forensic structural engineering. There are so many documents published by American Society of Civil Engineers which are extremely useful. One such document is this one, which is Guideline for Forensic Engineering Practice. Uh, it describes most of it describes how to do this profession, how to carry out forensic structural engineering, what all you need to take care, and also a lot of case studies are covered. There are many reference publications of failures and failure education. This is a list of those, and in fact, uh, these are available in just you go to Google, you will get many of these books simply downloadable, free downloadable. Not all, of course. Some you have to buy. For example, this one I had to spend some 5,000 rupees to get it from uh, US. Though it's a very thin book, but it costs. There are organizations offering failure related publications, trainings, and workshops, and most of them are in America. But if you go through their websites, you can attend the conferences. You will come to know when these conferences are happening, and you can attend some of them. They may cost you, but it is worth, I can tell you. There are several research papers available in IABSC or FIB on forensic structural engineering, and each and every paper are very, very interesting, I can tell you, because the real structural engineering is when you study the forensic investigation study reports. I will conclude by saying that never pass a failure without learning from it. Never discard what you have learned without using it. Always walk through the door of opportunity opened by a failure and look for improvement. Thank you. Thank you all for your patience.
Thank you very much, sir. It is a wonderful